Sugar analysis is a crucial process in the food and beverage industry as it helps ensure product quality, consistency of receipt, and health consideration. The common type of sugar analyzed include glucose, fructose, and sucrose. An accurate determination of sugar content is essential for product labeling, test consistency, and overall customer satisfaction. This analysis was involved high-performance liquid chromatography, or HPLC. It is a technique in analytical chemistry used to separate, identify, and quantify specific component in mixture. This method is predicted by Kelvin Gidding, Joseph Huber, and others in 1960.
Principle of HPLC. And HPLC, high performance liquid chromatography, is a chemical analysis method that uses pump to push liquid through column at a set flow rate. The injector adds the sample to the mobile phase stream, while the column separates sample component using physical and chemical parameters. The detector identifies each molecule eluted from the column, and the computer serves as a data system, managing all modules using the detector signal to calculate sample components, retention time, and also quantitative analysis. The fundamental principle of HPLC separation. HPLC is a method that separates chemical in a mixture through interaction with stationary phase and mobile phase. The mobile phase is usually a liquid, while stationary phase can be solid absorbent or a liquid contact surface. After being injected into the HPLC system, the sample will pass through stationary phase field column, and it will interact differently with stationary phase and mobile phase. This will cause them to separate accordingly to their characteristics such as charges, polarity, or size. Based on this table, there are 5 common separation techniques in HPLC. First is reverse phase chromatography. Second, normal phase chromatography. Third, size exclusion chromatography. Fourth, ion exchange chromatography. And lastly, affinity chromatography.
Next is sample preparation. First of all, why sample preparation is important for accurate HPLC analysis? It is because it can provide specific and more accurate results, removing interference, improving the reproducibility and reliability, and prevent damages of HPLC analysis. The common methods used for preparing samples in sugar analysis are sampling, filtration, dilution, and derivatization. These are the sample preparation steps involved in preparing a sample for HPLC. The first one is sample collection, which is using suitable sampling techniques to keep useful information. The second one is sample homogenization, which is stirring or shaking to make sure sample is representative. The third one is extraction and cleanup. It involves solid phase extraction, SPE, liquid-liquid extraction, LLE, or protein precipitation. The fourth one is concentration. It is to enhance detection sensitivity, use evaporation in solvent exchange or SPE. The fifth one is pH adjustment, which is using suitable acid or base to improve analyte stability, solubility, and chromatographic performance. Next one is solvent compatibility. Solvent use must be suitable with the phase and chromatographic conditions. And the final sample preparation is to keep the sample solution into suitable containers, then label the information and store in good condition. Next, the examples of sample types like solid or liquid and their preparation techniques. The first one is solid phase extraction. It is the separation of unwanted components and wash them away. The second one is liquid-liquid extraction. It is when two immiscible liquid phase mix with an organic solvent. And the third one is protein precipitation. It is the addition of precipitating agent like acid or organic solvent.
Hello everyone, I'm CHRYSTALLEO so I will be explaining about HPLC method development. So there are 5 methods, which is first, define the objective. Second, sample preparation. Next, a method development process. Next, documentations and standard operating procedure SOP. And lastly, optimizations of HPLC condition. Define the objective, whereby we need to identify the analyte and purpose of quantitative, qualitative, and purity. For sample preparation, we need to consider sample matrix and appropriate preparation step, which include 3 steps, which is extraction, filtration, and dilution. Next is method development process, whereby we need to determine the steps in developing an HPLC method for sugar analysis and choose between UV, fluorescence, and mass spectrometry MS or refractive index RI detection. For documentation and standard operating procedure SOP, we need to record method details and create a detailed SOP. Last but not least, optimizations of HPLC condition. First, we need to identify the factors affecting the separation process, for example, column temperature, flow rate, and solvent gradient. Next, method to optimize this condition for better resolution and sensitivity. Lastly, start with initial conditions, systematically vary parameters, and conduct robustness testing.
This is the steps to running HPLC analysis. First, make sure you have all your buffers set up. Open the purge valve in the system for 5 minutes. Then add your samples into the auto sampler tray and stop the purge. Close the purge valve. Then you can run the system at a normal flow rate with your buffer to equilibrate the column for 10 minutes. Then make sure that your pressure is stable and set up your sequence and your method. Lastly, run a standard before your actual samples or as part of the same sequence. This is the figure shows the HPLC chromatogram of standard sugars, which are fructose, glucose, galactose, sucrose, and maltose. And this table shows the sugar content in dead palm fresh juice and processed product. In the table, all samples show a higher amount of glucose than fructose. Based on the studies, the samples were tested by more than hundreds of people in a different range of ages.
Next is the applications in the food industry. HPLC is used to ensure quality control in the food industry. For example, pesticides is used to prevent or destroy any pests and insects. Target analytes can be found and quantified using HPLC that can be used to monitor pesticide levels on food products, keep them within legal limits, and safeguard consumers. For the applications in the beverage industry, HPLC is used to make soft drinks like beer, coffee, and fruit drinks. HPLC can make sure the diluted syrup is within tolerance and measures the amount of caffeine, sweeteners, and preservatives quickly. And after being filtered, the controlled beverage is degassed and examined.
Some common challenges in HPLC analysis. First is no peaks. No peaks or very small peaks show up on the HPLC input. Second is no flow. Getting no peaks on the output means that there is no flow in the HPLC column. Third is pressure issue, which is air trapped in the system. Lastly is negative peaks. If negative peaks start showing up, it is possible that the recorder leads are reversed.
HPLC is an essential tool for the accurate determinations of sugar in the food and beverage industry. Proper sample preparation, method development, and understanding of HPLC principles are crucial. Despite challenges, HPLC applications in quality control, regulatory compliance, and health consideration make it invaluable.